Good news, everyone. I finally have finished putting the socket power unit all back together, and I'm ready to try powering it up again. I say again because if you watch an earlier installment, I did actually power this up with the rectifier tube out of the circuit, and I was able to get these filament voltages here. So I know that the power transformer is okay, and I also checked for continuity in the filter chokes. However, I've never tried measuring DC because I've never put a tube in here because the capacitors were bad. Well, all the capacitors have been replaced now, and I'm all done stripping the rust off and painting it and so on and so forth. I have temporarily wired in just a cheap old vinyl power cord here, no power switch, but I'll hook all that stuff up later once I actually get this thing working properly. Alright, so first I'm going to power it up again without the rectifier tube in the circuit, and I want to make sure I get these voltages here. So I've got it plugged into a 60-watt light bulb in series in case I've made any mistakes and there's a short somewhere, and I need to hook up my meter now. Okay, I've got everything set up for my test, so I'm going to turn it on right now. Alright, so far so good. The light bulb is still dim. No pops, no smoke. Let's see if we actually have any voltage. Should have 5 volts AC across these two terminals. And 4.92, I'd call that close enough. It's quite warm today, and I've got my air conditioning cranked up, so I expect my line voltage is drooping a little bit. Let's see if that switch works now, the line adjust switch. If you recall, when I first tried powering this set up, this switch was faulty, so I bypassed it. Well, I've since cleaned it, and it seems to be making better contact now. So I'm going to throw it into the other position. Now let's check that 5 volts again. Okay, now we've got almost 5.3. So this must be the 110 volt position. In other words, this is supposed to be 5 volts, so if you were in a location that had lower line voltages like 105, 110, you'd have the switch in this position. If you have higher line voltages, throw in the other position, and closer to 5. In fact, they say in the original RCA Radiola 18 info, which is essentially the same as the Brunswick 5KR, they say to always keep it in the 120 position unless you know for certain that your line voltage is too low. In other words, you want to run this as cool as possible with as low a voltage as possible so you don't stress out the components. Okay, the next pair should be 2.25 volts AC. 2.36, so it's pretty close, and then this should be 1.5. Now keep in mind there's no load on this, so I would expect the voltages to be a bit higher. Alright, now I'm going to turn this off and reposition things a little. So there's still no rectifier tube in here, but I do want to check the voltages in the rectifier socket before I pop a tube in there. And now you can get a nicer look at the chassis too. I cleaned everything up. Went over the socket here, it's a Novus number 2. And I put all new screws in here because the old ones were corroded. I polished up the speaker jacks, nice and shiny. Cleaned up all the terminal strip over here. Yeah, so we've got 4 pins on the rectifier socket there. The 2 larger ones are the tube filament. Should have 5 volts on those. And the other 2 are the plates. And each plate to ground should have, well, they don't specify exactly, but should be over 100 volts AC for sure. Alright, so I'm just going to stick my meter probes right into the 2 larger sockets. Should get 5 volts AC or thereabouts. Turn this back up. weird. Seems like this thing isn't getting any juice. Okay, let's try that again. I didn't have the plug plugged in very securely, and I wasn't making good contact at the outlets. Alright, excellent. 5 volts. Now, if I go between ground, which is the pin, lug rather, right here at the end, or actually either one. The whole chassis is actually grounded in this set. If I go between ground and either one of the plates, I should have 100 and something, maybe 200 and something volts. Okay, 290. It should be about 290 on the other side. Alright, so next thing I want to do is put an 80 rectifier tube in there. And I want to put on a bit of a load, because the caps are going to charge up, and with no load they're going to hold a charge for a while, and I want to bleed it off. So right here at the 165, I'll go between there and ground and throw in, oh, I don't know, I want to put a fairly moderate load, or very modest load, rather, like 20 milliamps or so. So I'll do a little math and throw on a resistive load there. I just happen to have a 10,000 ohm power resistor handy, which makes the math really easy. I've got that across the 165 volt bus. 165 volts DC with 10,000 ohm load is a 16.5 milliamp load. And that's about 2 3/4 watts. This is a 10 watt resistor, so no problem there. I'm not sure how much the receiver chassis draws in normal operation. I'm sure it's more than 16.5 milliamps, but probably not a whole lot more, so I think this is a reasonable simulation. I've got a used but good type 80 rectifier tube here. Pop that in. I've got my DC meter attached across the resistor. So let's turn this on. Alright, voltage jumped up right away to about 177 volts. So as I said, I think the set will draw a bit more current normally, so that voltage will drop down a little bit. 177 is pretty close to 165, and more importantly, it's working, and we have DC voltage, and everything seems to be holding steady. Alright, I'm going to leave this sit and run for 10 minutes or so to make sure no problems crop up. And then I think we can call the socket power unit chassis done for now, and I'll move on to wrapping up with the tuner chassis. Now as for the receiver chassis, here's where things currently stand. I have gotten pretty much all the rust off and primered it. Got the top done. Now I'm doing a little more work on some of the mounting points. Especially this one's bad around that nut there. Got some navel jelly on it. Once that rust is cleared up, I'll put some more primer on that. And as for underneath, I've removed pretty much everything that's convenient to remove. These last few things are riveted on there pretty well. Like all the tube sockets are on one big light plate with a whole bunch of rivets, so I'm not going to be taking that out. Then there's this little board here with 3 capacitors and 1 resistor on it. It's in pretty decent shape. And this is a compensating capacitor. There's a hole through the top of the chassis there. It's basically the only alignment type adjustment you can make in this set. Got the coils out. I think I showed how I removed those earlier. Well, I went a step further and actually removed the mounting plate because all the, this strip was rather rusty, and with it riveted in place I was having a hard time getting the rust off and repainting it, so I just drilled the rivets out and I'll reattach it once I've got a nice coat of paint on it. I already removed this and rebuilt this in an earlier video. This box cap that goes up in here, and then here are the audio coupling transformers. I wasn't planning on taking this out until I noticed that the paint was flaking off quite a bit, and it actually was fairly easy to take out. 4 tabs going to the top of the chassis up in here, and I was able to bend them back quite easily. And now that it's out, I've got some naval jelly going on these tabs, all 4 of which were fairly rusty, and then I'll go over this. As I said, the paint is flaking off, like you can see. And there goes a chip right there. So once I'm done with the naval jelly, I'll clean this off and start sanding it, and probably take off most of this paint just with some sandpaper, and then primer and brown paint. Now, once all that primer and painting is done, I can start reassembling this